Hi everyone, and welcome back to part 5 of writing Tetris from scratch in Rust. Last time we focused a lot on trying to construct the basics of getting input into the thing and getting it to display actual pieces. And today we're going to probably dive a little bit deeper into more of the controls, getting some of the gameplay working, and generally have a good time with that. There was one thing that I found after the end of last stream where there was a bug. I skipped ahead a little bit to try and make sure that everything was going to go smoothly this time, but I found a bug in one of the things that I had previously written, and that is in the isClipping method here. And it's just a little tiny logic mistake. If you take a look at the diff here, it used to be we would check if we would consider it to be clipping if it was either not on the matrix or if when we index into the matrix there was a piece there in the place that we're trying to place. But there's a mistake there, which is that when we replaced on matrix with valid coord, not all of the valid coords are on the matrix. And if you try and index into a coord, that is not on the matrix, it panics. And so I adjusted this to be more accurate and actually check if the coordinate is valid before trying to index the board. Typically, you might also get around this by, instead of using the index trait, having an explicit getter method, which returns an option. But I figure here it's better to do it explicitly because we are also using the valid coord method to do a different explicit check. And so if we keep those on the same level, then that's going to be a little bit easier to understand. Oh, and another thing that came up since the last time, somebody left a comment on my previous stream asking me about a design decision that I made. And that design decision was the decision to separate out the conversion from the engine's color into the interface's color in a trait, rather than putting that on an inherent method of color itself. And that trait is here in render traits. Screen color is the trait that I wrote, which will convert from the semantic color, which is the engine color, into an SDL color, which is imported from SDL2 here. And the reason that I chose to define this here inside this trait, rather than just making this an inherent method of color in the engine, was because I'm designing this such that the engine is sort of a self-contained unit. And if we, for instance, wanted to write a TUI, a CLI interface for this, that would no longer really make sense. And what this allows is the ability to separate out the definition of interface-specific components to be exclusively defined inside that interface. So if we were to, rename interface to SDL2 interface and then have another one which was like a TUI interface, we would define a separate screen color trait, which instead of converting it from a semantic color to an SDL color, it would convert from a semantic color to whatever color the TUI library that we were using is. And each of those would be completely separate, and the engine wouldn't have to know about either of the implementation details of the interfaces. And so that's why I put this here. So let's look at where we were last time. So yes, we were here. We had the T piece, and we were able to use the left and right arrow keys to move it, and it stays in bounds of the thing because it attempts to move and then doesn't move it if it can't. We also implemented the hard drop, and the thing that let me know that I had a bug was I had gone into the main here and changed this from a 5 on the Y to a 20, which puts it above. And I guess for accuracy, I should put this at 19 because that's, I think, where each piece is introduced. We put it up here. It's important that that is still a valid place for the piece to move. Otherwise, it won't drop, and it will panic if you try and index out of bounds. So what this allows is movement here, and then still the ability to drop because that's a valid place for the piece to be. and it doesn't have any programming errors with actually using those positions above the board. So I think probably the next thing on the list is going to be, we're going to, of course, remove this at some point. But I think for now it's going to be useful to keep around and then just remove it later, because we're going to want to test a lot of edge cases, and we could theoretically just replace it with a more structured way of introducing state into the thing for testing purposes. But since I wanted to test it top down, this is kind of a necessity of the way that I had written it. The way that we were going to do the timing was using the built-in SDL2 timers. If I locate where we were. Right. Wanted to keep that as an. This is interface map. Guess we can also remove these since, well, I won't remove this yet. So we have, if I remember correctly, we have in the engine the definition of how much time each tick should be. Drop time. Yeah, that returns a duration, which we then pass into the. Oh yeah, I also realized that we don't have to have this this wrapper struct here for sleep, since we are no longer passing in a custom message to a queue. It's just gonna handle it. Or wait, do we? No, I think we do. No, we don't, because we're calling the sleep thing directly from SDL2. This was going to be necessary if we had a custom user event type that we needed to put this in so that we could map it across to the other side. But since we are explicitly calling the timer method, which I'll pull up the documentation for, that information is instead encoded in the method name that we're calling instead of in the struct that we passed into the event loop. So SDL2. Segmentation fault. Wow, that's something you'd rarely ever see in Rust. That means that this API is not memory safe. That's alarming. Sync. So ident x per sync here. Subsystems cannot be moved or usually used on non-main threads. So why is your type sync? RC restricts use to the main thread. What? So in the meantime, we do have other stuff that we can work on. Namely, the thing that happens once the cursor is hard dropped, because what we have to do after that is to go through the board and then see basically what happens after the player has done their input. So if a piece locks down here, and I can set up a I can set up a scenario in which case it would clear a line so that we can try it out without actually having a timer. So here we're going to record in, and then I just make an array because arrays implement into iterator now. So that'll just go. It's going to be actually we can do for column in, and then it's 10 wide, and we want to go from 0 to 6. And so we're going to go 0 to 7 exclusive. If we wanted to do 6, we could say 6 like that, but yeah, let's do 6 like that. I think that's currently accepted syntax. Yes. We can say the column is the X here. And so column, and then we're going to do this on the bottom. What that's going to do is that's going to fill in a line across the bottom that just leaves 3 spaces. Yes, and so that leaves a nice little place where we can drop in this. And then after I press that, what that should do is clear the whole line at the bottom. So in order to implement that, we go into the interface, since the interface is where this starts, since it manages the order of events that happen. Collapse all this stuff. After we get an event, I think what we should do here is have another flag. Do we need another flag? We could theoretically reuse dirty. But if we wanted to be more precise about it, we would introduce a new event type here, which would be, this would represent if a piece was locked down. And then we don't need the annotation here because we initialize this immediately, and it's a bool because true and false are bools. So lockdown is false. And then at the end, what we want to say is if lockdown then we want to scan the board to see what lines need to be cleared. Thinking about how to do it, there's a really easy way to do this naively, which is just to scan through, see which ones are full, remove them, and then say how many lines got cleared. But what that does is that ignores two things. That ignores, I don't know if the line, no, that's not a consideration. I was gonna say if the lines were contiguous, but that doesn't, I don't think that makes a difference. I think you get the same number of points for clearing lines that are right next to each other and lines that are far apart. So, the other thing that precludes is the ability to do animations, because if you have an animation, you need to give the interface the information it needs to run that animation, and the thing that is the indexes of which lines are being deleted so that it can then run the animation. And then after that, you can either immediately remove them and then let the interface make it look like they were animated out of the way, or what you can do is tell it which ones need to be removed and then have it play the animation and then manually remove them. And considering that the way that we have set up our animation here, where it's very dependent on the information, it doesn't keep persistent information about the previous board state, I think the latter solution makes the most sense, because if you had a method which was like it removed the lines that were full, in order, between the time where you remove them and it says which ones were removed and the time when it has completely removed them from the screen, it would need to itself keep track of what was there. And I'd rather only keep track of that in one place rather than have an additional layer of caching over top of it. So what I think we're going to do here is use a handle type. We're going to make a handle type. And the benefits of that are, if you make a type that is opaque and is not constructible elsewhere, that means that you can always trust what's inside that type. So SDL2 has a lot of opaque types in their API. For instance, timer subsystem, fields are omitted. And that's because they're all private, and so it wouldn't make sense to list them here because you can't access them anyway. But if you did want to see what they were, in here we have timer subsystem, which uses the subsystem macro, and it calls it with sync incorrectly, and says pubstruct name, and this is timer subsystem, and then all it has inside of it is an RC of subsystem drop. So in here, what we can do is create sort of a key type, which keeps track of the indexes of which it keeps track of the indexes of which rows were removed. And by keeping that member private inside of that type, that means that the interface can't incorrectly, like arbitrarily remove things. It always has to come from inside the engine. And that doesn't mean that it doesn't have any access to it. Of course, it has to have access to it because it needs to know which lines to animate for removal. But the way that you do that is you just add a method, and that returns explicitly what they are. It returns either an iterator or it's an array of the things that it's going to remove. But the important part is when you actually go to remove them from the board, that method on engine must take that key type. And since you can't, since that is always authentic, since you can't spoof that from the outside, it knows that that's always a valid thing. It must have always come from itself. It always must have requested its own removal. And there is one caveat to that, which is that if you get multiple removals without removing them, you can remove in the wrong order, I guess. Which of course we wouldn't do on purpose, but it's a good exercise to think about a way to mitigate that. And one way, of course, to do that is to just have an internal ID, which makes sure that all of the deletes are contiguous in the ID order. I'm trying to think if there's a way to do it with the borrowing system. And I guess you could do that if you had a method which would delete and then you pass it in a closure to run to execute the animation. Although I'm not sure how that would really interact with the rest of the system borrowing. It's an interesting enough idea, though. I think we should go forward with it. Which, of course, then would also mean that we don't actually have to have that key type. That would all be internal. Interesting. Yeah, let's do that. That sounds really cool. So the way that might be a little bit confusing. I don't know how good of a job I did at explaining that. But the way that this works is what we do is we have a method, a method on this. Hubfin line clear, which takes self-mutably because we will need to edit the contents of the matrix here. But it also takes trying to think of how this interacts. It would, what this function does here is it's a function that doesn't take any arguments, but it captures the external state. And all it does is change stuff in the environment. And in here, what that means is it changes the interface. It draws and clears the interface. And here, I think that's just imposter. Which, oh yay, is in the prelude, so it's automatically in scope. What this means is that it's a function. It implements the function trait, which means that it's executable, and it implements the mutable version of the function trait, which means that on the back end it takes a mutable reference to the function object, and the implication of that is that that function can then alter variables and state that it captured externally. So here we need that because we need to mutably borrow the canvas in order to draw the animation. But so here, the order of operations here is to identify full lines. Or yeah, this does take an argument actually. And here, the thing that it takes is a reference, or yeah, this will take a slice of indexes that it will animate being removed. So this is going to be, oh, what are we using to index here? Internally, our coordinates are represented as 0.2s of usize, so we can just use usize. Identify full lines, and then we can very rustily say let lines equals do identify full lines. Should never use a comment when you can write code that says the exact same thing. And then this is going to be either an array or a slice. This would have to be an array, right? Or a vector. Because we could have it be an array. And then either have no, because then we'd have to map it to an array of indexes if we put in optionals. I think a vector is going to be fun. One extra heap allocation in the line clear animation is not going to detectably impact the performance. So this is going to be a vec, I expect, of usize. And then what we do is we call the animation function with lines as slice. And then that's just going to remove all of those. Trying to think if there would be any value in making this generic implementing iterator, but I don't think there is. I think it would just be fine. So we do the animation, and then after the animation, we actually remove those. And one thing that I remember very distinctly from previous implementations of Tetris that I have written is that the way that you remove these lines is really important, because you have to start from the top and work down, because if you start from the bottom and work up, the second you remove those lines, all the rest of your indexes are invalidated. So here, I don't know if we want to, for the animation, it doesn't make a difference what order they're in, but here we can internally maintain that invariant that these are always sorted from least to greatest, or greatest to least. And we don't have to worry about that getting screwed up because all of the logic is contained within one class. And typically it's, we wouldn't like validate is sorted. We could do like a debug validation. That's actually a good idea. Debug assert lines dot is sorted. But in normal, like we won't have to actually check that because nothing outside would be able to introduce a set of lines that weren't sorted. And for some reason, this is behind a feature flag, so I'll just go ahead with that. All right, so then what we do is we iterate in reverse. Or I guess we can delegate, at this point we can just delegate to the matrix. And because this is going to be a private method of matrix, we can, again, sort of assume that they're going to be in the correct order because nothing outside of this module is going to be introducing lines out of order. But here, what we'd say is and then a slice of lines, and it's similarly with the order is also the length. Like we're never gonna be clearing more than 4 at a time because all of the pieces have four blocks and it's impossible to clear more than 4 lines. So a slice of usize, which is going to be called indices, and then in reverse order. And then we're going to say here self dot matrix dot clear lines dot as slice because it's a vec. So now what we have to do is logic to identify the full lines, which can also be done as a method on the matrix. And this shouldn't be public, this should be private to the mod. Full lines. Self returns a vec of usize, indexes of the lines that are full. And this doesn't really matter. So what we can do is say Oh wait, this is on the engine. This should be moved. Oops. Here, to make this a little bit nicer, we can also say, we can have a method called like lines, which returns an iterator over slices of each line of the thing. And the easiest way to do that is going to be, I think, using a standard library trait called exact size chunks. If I look for chunks, slice chunks exact. And then this takes a reference to self and a chunk size. And oh, stop. Returns an iterator over chunk size elements sliced at a time starting at the beginning. Chunks are slices and do not overlap. If the chunk size does not divide the length, then the last is up to chunk size -1. Last up to chunk size -1 elements will be omitted and be retrieved from the remainder function of the iterator. Is there one that returns an array? Array chunks? Experimental. Yeah, so this is going to return a reference to an array. Array references. So this is returning, instead of a slice, which is a dynamic type behind a fat pointer, this is going to be a static type behind a regular pointer, which takes basically a slice of that memory in place. It doesn't actually copy any of the elements, but it encodes, instead of encoding the size as the second portion of the fat pointer, it encodes it as part of the type, and then that gets erased at compile time. And so that doesn't actually end up inside the code that ends up executing. And what that allows is more reliable, more aggressive optimization around things like loop unrolling and different things to do with bounce checks and that sort of thing. So I think that's what we want. This returns array chunks. We don't want input because we're not editing them, we're just observing them. And so this is going to be array chunks of the lifetime from self. And so we can infer that. And then T, which is the type that is inside that we're iterating over, which is an option of color for now. And then N being the const parameter, which is the size of the array we're returning. Here we have that nicely defined as a constant, which is the width. So here what we can do is just say self.0 dot array chunks, or chunks, array chunks, which I think we're going to need to add another feature for. And then it's going to, I think, infer the generic parameter. Why are you complaining? Unstable. Yeah, so we need to add this feature. Type provided when const was expected. If this generic argument was intended as a const parameter, surround it with braces. Okay, thank you, Rust compiler. That's very helpful. Cool. So now that just works. So what this will do is say self.lines, which will call this method up here. Dot with index. Or dot, what is it? Enumerate, I think is enumerate. Self.lines.enumerate dot filter, and then we're going to filter to this. Enumerate will return a tuple of the index and the value, which in this case is a reference. And then we don't care about the index here, and so we can just say the line. And then that we're going to check if everything in the line is sum. Line dot iter dot all option is sum. I think that's true. Yeah. And then we're going to, ooh, we can use a filter map here. Because we are going to be, well, does that provide any? We can say, we can do it the plain way and just say dot map and then take the index and then discard the value. And then just map it to I and then say collect, which will infer the type from the return type. And that works just fine. We take the lines, we enumerate them with their index, we filter to where everything in the line is sum, and then we map it back out to the index and then collect it into a vector. The thing that I'm wondering if it's better to do is use a method on iterator called filter map, which does the filter and the map in one step. And so what I'll try to do here is write it as a filter map and see if that's better. Line. What we do is we say line.iter all option is sum, and then that gets mapped to, we discard it and it gets mapped to the index. And that is significantly worse, so I'm not going to do that. And one thing I might do to increase the niceness of this is just pull out this little closure. So let full equals and then this closure here. And then just filter based on full. And then I think this wants explicit type parameters here. And then that's just gonna, that ends up being too messy. So never mind, this is simpler. Although to increase the readability, what I might do is just put the expression on its own line here so that you can differentiate between the admittedly very symbol heavy declaration of this closures parameters from the actual expression that it evaluates. And I think that's doing. So where is it unhappy now? Wait, this belongs up here. Oops, that was dumb. This belongs on in. So then this becomes full lines, which returns a vec of usize. And then here, we need to mark this as mutable because it's a funmut and we are mutating it. If it was, we wouldn't have to mark it as mutable if we were passing it off and moving it into somewhere else, at which point that thing would mark it as mutable, but we are actually doing the mutation here by calling it, and the call method of funmut, which gets implicitly called by this call operation, does take it by a mutable reference. So there, I think that's, we want to move this down inside of matrix clear lines because this is the one that actually depends on it. If you lower your dependency validation to right where it needs to be validated, then you're going to decrease the likelihood of accidentally screwing it up. And then this is where we clear the lines in reverse order. So we have line clear. And so if we hop back over to the interface, if lockdown, then we can say engine.line clear, and then we pass in an animation which takes the indices and does nothing with them at this point because we don't really care. And that's private, so we want line clear so that we can call it externally. And then we want this one to be. All right, so here the thing that we can just pass in is drop. Also, stay tuned. I'm gonna have a video coming out on drop in a bit. So if this looks weird or interesting, get subscribed. You'll hear more about it. Line clear. And it looks like the lifetime requirements on line clear are not quite. Yeah. The reason that this is happening, I think, is because these two references have different lifetimes. Because the lifetime that we're borrowing self for here is not the same lifetime as is being used in this. And so we can just use this syntax, I think. Anytime you see ones and twos in your error messages, it's a good idea to add in explicit lifetimes so that it, I think, will fill it in. We'll see. So if I have lifetime this, and lifetime slice, which needs to be generic parameter. And this also needs to be a generic parameter. Or if I can just put a underscore here to just say that it's different. Lines dropped here while still borrowed. How do I express? how to express that this does not leave. This is getting into some advanced lifetime shenanigans, because this function here, if I'll put these on different lines so that it's a little bit easier to read, because this function here that we're passing in could possibly take this reference that we're passing in and then assign it somewhere else, and then that reference would outlive the scope of this function. And because this shouldn't be generic, because we could pass in something like static here, and then this would take a static reference to a slice, and we are unable to provide that wide of a reference. So how do we say that? If I take this away, let's see what implementation of fun once is not general enough. Stdmem drop of reference or lifetime 2 slice of usize must implement slice or lifetime 1 slice of usize for any lifetime 1, but it actually implements fun once slice lifetime 2 of usize for some specific lifetime. So how do we make it so that this can we say that? What's the function signature of funmet? As args, we have an unnameable lifetime here that refers to a specific lifetime inside the function. So what I'm going to do is, instead of using impl function here, I'm going to do a generic parameter f, and then have a where clause. And then here we say F to pay respects. Can I restrict this lifetime? What happens if I replace this drop with a closure? Toilet closure time. That works. There we go. I think that specific implementation, taking drop as a reference to a function, did not allow the compiler enough leeway with the lifetimes in the way that just a very inferred closure like this allows. So that's fine, actually. So I think we can actually just put this back. That should be fine. Right? Let's see. Patterns. Ah, that's why. Yeah, that works. Cool. Compiles, it's happy, everything's good. So, next thing we have to do is that to-do. Or I guess we can run it here, because we have it up to the point where we actually call line clear, and then at this point it should, yeah, it should call the thing that has to-do and then crash. And so as long as it crashes with the right message, run, it's over here. It didn't. Very, very good. And the reason it didn't is because we never set lockdown to true. So in here, hard drop. So there are a couple places where we need to put this. We need to, when there's a hard drop, we hard drop and then mark it as locked down. And then similarly with the lockdown tick. And so this, once it gets the hard drop, should invoke this. There it goes. Yeah, just what we wanted. Clear lines in reverse, not yet implemented clear lines in reverse order. So for this, I'm gonna look for methods on vector. Which is called vec. Looking at remove. Remove takes an index, which is usize. Can we remove a range? Up to the top. Looking through the function signatures to try and find one that takes a slice or a range instead of a usize. Drain. And so because this says in drain, it takes a range, and the type of the range is range bounds. I can search the page for range bounds to see if there's anything else that takes a range bounds. Like send from within, splice, copy within, drain. Those are the only things. So I think what we need to do is drain that range and then drop everything that was inside. So inside matrix. Oh, and then of course extend the matrix from the top. Where was it? Matrix. Sorter. So what we need to do is identify in reverse order. So we say for line in, for index in indices dot iter dot rev. And rev is a method that is implemented on double-ended iterators, which just wraps the iterator and then calls next back, I think is what it's called, repeatedly instead of next. And so that just goes off of the other end. So here, we're going to take, for each line, we're going to construct the range of indices that are on that line and then drain and drop that. So, and say, guess we do some wishful thinking and say, from the range of line, and then we have, that's actually just going to be a static method because that only operates on, yeah, a usize, which is the index. And then that returns a range bounds. What's a range bounds? Ops, range bounds. Trait. It's a trait. So this returns, this takes something that implements range bounds. And the implementers are all of the different range types. So in this case, what we want to do is just a standard range. And of course, because the you could pass in an index that is just completely out of range of the thing, we could return an option of a range. Of usize. And then that. To do. So then here's the thing. It returns an option and we want to panic. We know that it's going to be inside the thing, and so we can be fine with just panicking if the range is outside, because we're not going to pass in a range that's not in the range of lines in the board. So here we can just panic. That happens. So range equals range of line yourself. Range of line, pass in the index, and then unwrap, because we're not gonna break it. And then we can say for self.0, I think, because this is a unit struct, yes, with a giant array, and say self.0, which is the array, Oh, it's an array. It's not a vec. Damn it. Is there a similar thing on array? If not, we can just take it as a mutable slice and then swap in. There's no drain. So slice, primitive type. We can I want to remove, but remove a range. I might end up just replacing that array with a vec. Or I could just copy everything out into a vec and then do my operations and then assign back into the array. Wouldn't be that much overhead. Although I would like it if I didn't have to. If we have to do this by hand, it'll be fine. But I'd rather not. Copy within. Ranges may overlap. Yeah, I think what we want to do is take the full array and then copy everything from the line that we want to remove up, down one, and then fill the top in with nuns, I think is what we want to do. Yeah, self dot zero dot copy within, and then we have our range that we want to get rid of, but we don't want that. We don't want this in it. We want the start of the line following. And then we have to deal with the edge case of being at the top. So here, say range of line. So now we want to zero. So we multiply the width times the number, the index of the line. Yeah. So we have the width times the index, which will be one past the end of the line. Yeah, because zero, no, that's the start. Because if it's index 0, we multiply that by 0 and get that. And if it's the first line, or not first, but line 1, not 0, it's the width multiplied by that. So this is going to be times index plus 1. Is the start of that. And so basically what we need to do is say, this is the end of the range that we want to delete. Right, what is the actual... source is this range here. And then the dest is a U size, is the starting index of the range within self to copy to, which will have the same length as source. So I think this will work. So we've got, this is the start of the remainder. And so we want to copy from the start of the remainder, and then the number being the number of lines to the top. So if it's 0, then that's going to be 20, and if it's 20, then that's going to be 0. So that's the height minus index. Why does this be unhappy? Oh, start. It's the start of the remainder to the end. So we just use that open range syntax. And then after that, now that we've copied that down, we have a row at the top to fill in. And so then we just say, assign the top row to nones. And we'll end up overwriting that a bunch when we don't need to, but it's going to be just as expensive to check and see if it's already a bunch of none. Than it is to just do that mem copy of the 10 bytes. So we can just do an assignment, I think, or a fill. Fill with. Or no, fill with takes the whole thing. So what we need to do is take the last line. Is there like a fill or range? Or I guess I can just do, I can just slice it. Self.0, and then I slice it at self count. Self.size minus self width up to the end. And then I say fill with, and this automatically takes immutable reference to this bare slice that got dereferenced here. Fill with none. Oh, that's fill with, not, I just want fill. There we go. Fill with takes a function. There we go. I think this should work. Let's see if it works. Hey, crash. Dest is out of bounds. Oh, it's self height minus index times width. Right? What does that represent? Copy within. Copy within, where dest is a U size representing the starting index of the range within self to copy to. So this needs to actually just be index times self width. Hey, it worked. And then as part of the lockdown, or no, the lockdown, we already took care of that under hard drop and that locks down. Cool, so since that successfully cleared the line, I think for now I'm gonna do like a, oh boy, is that even gonna be, oh, that's gonna be a huge pain. I'll probably set that up before next stream, trying to test this more thoroughly. It would be a little bit difficult to unit test this, it'd be really clunky. So, because this is just a frivolous project, I'd be happy with just manually testing it. And I think I'll try and get that set up, as well as figuring out the weirdness with pushing an event from a different thing. If I need to fall back to my original plan of having a channel which performs the sleeping externally, that'll be fine. I can just, you know, do it the way that I was going to do it in the first place. Yeah, really unfortunate that that happened, but yeah. Cool. So I think that'll be it for today. Make sure you get subscribed. I've got some edited content coming out soon. Still working out the kinks on that because I'm not I'm not a practiced YouTuber, so yeah, that's in production. So yeah, I'll get back to you with some fixes for this and see you next time.